Today we are going to talk about the natural response of RC circuit. In the previous class, we were talking about RL circuit. But today we are going to talk about RC circuit. Imagine that we have circuit like this. And what I have R and C. And I have another R here, which is R1. And I have a battery here, VG. Imagine that this switch was closed for a long period of time. And there was no closed switch here. This guy was opened. So during that time, I don't have this part, but I have only this part of the circuit. So if I have this part of the circuit, this guy is DC. VG is DC source. And I have a capacitor here. So the capacitor looks like what? The capacitor looks. The capacitor at that time, because of the DC, looks like an open circuit. And what is going to happen right now, the capacitor is going to be charged. I will try to leave this switch closed till the capacitor is fully charged. So what is the value for the voltage across the capacitor after being fully charged? It will be equal to VG. Based on that, I'm going to say if this guy is moved to close that part after t is equal to 0, I will imagine that after t is equal to 0, I'm moving that switch, which is after a long time. The new circuit will look like this. Oh, sorry. This is before moving the switch. So the new circuit will look like this. So before moving the switch, if the switch is here, the circuit will look like that. And this guy is going to be charged. And this guy looks like an open circuit. That's why what's going to happen, the charge across this guy will be VG after a long time. After that time, I try to move this switch from that spot to that spot. If you move the switch to that spot, this circuit is going to be open or closed. This part of the circuit, it will be opened. So I will not need that part of the circuit. Based on that, the new circuit will look like this guy. I have only R and C connected in series. What is the initial charge after moving the switch? The initial charge between these 2 points, which is VC of 0, is equal to VG. Again, at time t is equal to 0, it doesn't mean the starting time. No, it means the time after moving the switch. Before moving the switch, I have another time. After moving the switch, I'm talking right now about RC circuit. For RC circuit, I have a charge across C, which is VC of 0. Now, I have RC circuit, and they are connected in series. My question right now, this circuit is called step response or natural response? It's natural. Why? Because I don't have external voltage source or external current source. What is needed? I would like to find the voltage across R. So I'm going to say summation the current across this node or around this node is equal to 0. I have two different currents. The current from the capacitor and the current in this guy. And based on the direction, I could say plus or minus. I'm going to assume that this is the direction for my current coming from this guy. So if this is the direction for I, and the current for this guy has a direction also, which is current across R itself, so I can say this current plus this current should be equal to 0. I know that I can have negative current value because one will be positive and one will be negative. At the end, I have one current. But I'm assuming that I have two different currents because I would like to find the relation between the voltage across R and the capacitor itself. So I will say the current here from this guy is equal to what? The current from this guy is equal to C dV by dt. If this is positive and this is negative, and this is positive and this is negative, I can say I have current in this guy and current in this guy. So the current coming from this guy is equal to C dV by dt, and this is what we studied before while I was talking about the capacitor. I told you the current across the capacitor I is equal to C dV by dt. What about the current across the resistor or inside the resistor? It's equal to the voltage across the resistor divided by its resistance value. So I can say C dV by dt plus V over R should be equal to 0. Now, this is first order differential equation, and we studied in mathematics how to deal with the first order differential equation for solving it, for finding V of t. So for solving this equation, in the previous class, I told you I can use separable method. Do you still remember? Separable method, what I have to do, I will move this guy to this side and leave this guy in that side, and then put everything related to V in one side, everything related to T in the other side, and then T the integral for both sides. And we did that in the previous class. At the end, you will reach to this equation, which is saying V of T, V at any time T is equal to V of 0 multiplied by e to the power negative t over RC. Again, for this circuit, how many C did I use? I used only one capacitor. How many resistors did I use? I used only one resistor. So if I have many capacitors in my circuit, if I have many resistors in my circuit, what am I going to do? I have to find C total and I have to find R total. Why? Because I derived this equation based on I have only one capacitor and I have only one resistor. So if I have many R and many C, I will try to simplify my circuit to have only one R and one C and find R total and C total. And after that, I will say V of T should be equal to Vc of 0, which is the initial voltage stored in the capacitor multiplied by e to the power negative t over RC. He is telling me that the voltage across the capacitor is not changing instantaneously. What does it mean? It means if you try to go back to this circuit, the voltage across this guy, if it is immediately before moving the switch, which is at time t0 negative, if it was equal to Vg, after moving the switch immediately, which is time t0 positive, the voltage will be Vg. Because the voltage across the capacitor is not changing instantaneously. So the voltage across the capacitor immediately before moving and after moving the switch, it is Vg. But let us look to this circuit. The voltage before moving the switch immediately across R, the voltage across R before moving the switch is equal to what? 0. It was equal to 0. But after moving the switch, it became the voltage across the capacitor. After moving the switch, it is changing because I have another circuit. So the voltage across the capacitor is not changing instantaneously. Voltage at t is equal to 0 positive across the capacitor is equal to voltage at t is equal to 0 negative. That's why when I derived this equation, I said this equation is valid for any t greater than or equal to 0. Is it 0 positive or negative? It doesn't matter. Because the voltage across the capacitor is not changing instantaneously. That's why he is telling me here Vc of 0 negative is equal to Vc of 0 positive is equal to Vg. If we try to assume that tau, which is the time constant, is equal to Rc for simplicity for writing the equation, I will substitute here by tau equals Rc, so I will have e to the power negative t over tau. Based on that, I will say V of t is equal to Vc of 0 times e to the power negative t over tau for any t greater than or equal to 0. This is the voltage due to charging the capacitor at any time. I charge the capacitor, then the capacitor will start to discharge its charge. As t is increased, what's going to happen to V? As you are increasing t, what is the value of V? Is it increased or decreased? It is decreased, and this is logic. Is it logic that the voltage across the capacitor will be decreased by the time?
Because it's discharging.
Yes, it is logic because, like what he's saying, the capacitor is discharging. So if you would like to draw this equation, you will find that if we started from Vc of 0 here, the capacitor will start to discharge. At t equals a specific value, the charge will be 0. We are assuming it is at t is equal to infinity for the capacitor. But infinity doesn't mean infinity. It means the time at which the capacitor will have 0 charge. So I can say that Vc of 0 times e to the power negative t over tau is equal to the voltage for the capacitor at any time t. And as you are increasing the time, the voltage will be decreased. And this is logic because the capacitor is discharging its charge during that period, which is from t is equal to 0 to infinity. Now, what about the current? If you would like to find the current, you can say the current in this guy is equal to V over R. Or you can find the current based on the capacitor equation. The current based on the capacitor equation is equal to what? I. Do you still remember the equation for the current in case of the capacitor? I for the capacitor is equal to C dV by dt. So if you would like to find the capacitor here, you can say I is equal to C dV by dt. But if I hate to deal with first derivative, I can say I is equal to V over R. That's fine. Because the current in this guy is the same like the current in the resistor. So I can say the current is equal to V over R, which is equal to what? Which is equal to this equation divided by R. This is in case of t greater than or equal to 0 positive or negative or any 0. Positive, because the current in case of the capacitor is changing instantaneously. Before moving the switch, the current was 0, but after moving the switch, the current is changing. Why? Because the capacitor at that time has a storage energy and the voltage across the capacitor is not constant, it's variable. Before moving the switch, the voltage across the capacitor was constant because of the charge. It has Vg. But after moving the switch, right now, the voltage characteristic is changing. I have a voltage across the capacitor, but by the time, the voltage value will be changing because of this charging. As if you have variable voltage, not constant voltage. That's why, in the second case, after moving the switch, the capacitor is not open circuit. Why it is not open circuit? Why? After moving the switch. Because I have variable voltage across the capacitor, which is Vc of 0 times e to the power negative t over tau. As you are increasing the time, the voltage value will be changed. That's why the capacitor is not is not looking like an open circuit for the second case after moving the switch. So I is equal to V over R, which is Vc of 0 over R times e to the power negative t over tau. Again, for t greater than or equal to 0 positive. Then if you would like to find the power P of t, it's equal to V of t times I of t. So you will multiply this guy by this guy. It will give you Vc of 0 square over R times e to the power negative t over tau. Last thing, if you would like to find the energy W is equal to integral of P dt from 0 up to t. So the integral of this guy will give you half CVC of 0 squared times 1 minus e to the power negative 2t over tau for t greater than or equal to 0. These are the 4 equations that I have already derived in case of resistance, in case of inductance, in case of capacitor, and also the 4 equations that I have already derived in case of our RL circuit, natural response, and today I have already derived 4 different equations in case of RC natural response. Next class, I will talk about the same procedures, but instead of saying natural response, I will say in case of the step response. So if I have the same circuit, but I have another voltage source here or current source connected to that circuit, what's going to happen? In case of I have a current source for this circuit, what's going to happen? This guy is called the step response. What is the voltage value? What is the current value? This is what I'm going to talk about on Wednesday. But let us see right now example which is talking about that story. Imagine I have this simple circuit. This simple circuit has 2 different capacitors. The first one, which is 5 microfarad, and the second one, which is 20 microfarad, and I have a resistor which is 250. And he is telling me that the switch is closed at t is equal to 0. So he didn't give me the whole circuit before and after moving the switch. He gave me the next part, which is after moving the switch. And he told me that after moving the switch, the initial voltage across 5 microfarad is 4 volts. And the initial voltage across 20 microfarad is 24 volts. And pay your attention, I have different polarities. Then he is asking me to calculate V of t, which is this voltage, and I of t. The question that I have to ask myself right now, am I able to use this equation for V of t in this circuit? The answer is no. You have first to modify the circuit to be able to use V of t equation. You derive V of t equation based on you have only one R and one C. If you would like to use this equation, you have to find C equivalent and R equivalent. And don't forget, you have to find the initially charged equivalent. So I have 2 capacitors connected in series. How to find the total capacitance? Is it sum? They are connected in series, so 1 over C total is equal to 1 over C1 plus 1 over C2, or I can say C total is equal to C1 times C2 divided by C1 plus C2. And don't forget the total voltage. The total voltage is the summation or the difference? It is the difference because of different polarities. So the first step for solving this problem is to convert this problem to be like you have something like that, only one capacitor and one resistor, so 250 kilo ohms. And I have here I of t, and this guy is V of t. And this guy will be the total. And the total voltage will be 24 minus 4. Right? So it will be 20 volt in that direction. Because this guy has positive, negative, and this guy has negative, positive. So the total from that point to that point will be 24 minus 4 in the direction of 24, which is 20. Now, what about C total? I will say C total is equal to C1 times C2 over C1 plus C2. So this guy is considered as C total. So C total will be equal to 5 times 20 divided by 5 plus 20 which is equal to 4 microfarad. Now, I can use my equations for finding V of t and for finding I of t. But before finding V of t, I have to find tau first. So tau is equal to what? Actually, tau is equal to R times C, but don't forget R total times C total. I have only one R. So this guy will be equal to R, which is 250 multiplied by 10 to the power 3 multiplied by C total, which is 4 times 10 to the power negative 6. So at the end, this guy will be equal to 1 second. Then you will write your equation, which is V of t equals Vc of 0 times e to the power negative t over tau. So this guy will be equal to, this is in case of t greater than or equal to 0. This guy will be equal to Vc of 0, which is 20, multiplied by e to the power negative t divided by 1. So this guy at the end, it is equal to 20 times e to the power negative t. Like what you are seeing, it's straightforward the problem. I'm using the equations for substituting for finding V of t. Then if I asked you to calculate I of t is equal to what? Actually, I of t is equal to V over R. So I can say I of t that you asked me about, this is for part A. For part B, you asked me about I of t. I of t is equal to V of t divided by R, which is equal to 20 times e to the power negative t divided by 250,000 because it is 250,000. This guy will be equal to 80 times e to the power negative t microamps. This is in case of t greater than or equal to 0 or 0 positive or 0 negative. It is 0 positive. I can give you for the final exam a problem similar to this, but instead of giving you 2 capacitors, I can give you more than 2 capacitors. I can give you more than 1 resistor connected in series, parallel, and so on. And then I'll ask you to find the equation of the voltage, the equation of the current. But before you start solving the problem, what you have to do is you have to find R total and you have to find C total first. I can ask you also to calculate the voltage across 5 microfarad or the voltage across 20 microfarad. That's okay. How to find the voltage across 5 or 20? Should I distribute the voltage by using the voltage divider? Did we study something like that? No, we didn't study distributing the voltage using the voltage divider. So how to calculate the voltage across 5 microfarad or 20 microfarad? What's your opinion? How to calculate the voltage? Here I calculated the total voltage between these 2 points. But if I asked you to calculate the voltage across 20 or 5 microfarads, what I asked you here, I asked you to calculate the voltage between these 2 points, which is V total. What about if I would like to find the voltage across 5 or 20 microfarad? What should I do? Excuse me?
Sub it into the 4 times 10 to the negative.
What are you saying?
You take your microfarad value and sub it into the.
No, we didn't study something similar to that.
Can we do V equals 1 over C integral of I, because I should be the same?
Another opinion? Yes. No, it is not preferred for that. This is what he said.
Use a ratio between.
No, we didn't study something related to the ratio for the capacitors. Yes.
Can we use the V naughts that are provided and insert it into a different equation, like a similar equation for the capacitor?
I think he mentioned something similar to that. Yes.
Find
the total voltage between the two
Yeah.
capacitors at t equals 0, and then since we're probably going to be given one of the
Yeah, but I would like to find the voltage at any time. Yes.
Voltage divider?
No, we didn't study how to use the voltage divider in case of that, because I have C, I don't have R. Yes. So, like what he said, we started I is equal to C dV by dt, right?
And we know that V is equal to 1 over C integral of I dt plus the initial voltage. So if you would like to find the voltage across 5 microfarad, what you have to do is you are going to use the current equation. And you will say the voltage across this guy will be equal to 1 over C integral of I dt, right? Plus or minus the initial voltage based on the polarities of the voltage. And by the same way, I can do that for 20 microfarad. So if you would like to find the voltage across each capacitor, you don't have choice. You have to use the equation that we have already studied before for the voltage across the capacitor, which is 1 over C integral of I dt plus the initial voltage based on its polarity. Do you have any question, guys? Thank you. I'll see you next week. Sorry, next Wednesday.